So this is a 26-meter dish.
Yes.
Initially, the Americans, when they built the dish in the 1960s, they had just a mesh surface and a prime focus, which means the radio waves came down, hit the surface of the dish and went up to where that sort of plate thing, it's called a subreflector,
Yes.
is, and then received there. Whereas with this having the cone in the center, that big cone, and the ice cream like cone on the side is for 18 centimeters. In the cone in the center you have everything 13 centimeters, 6 centimeters, 3.6, 5 centimeters, 3.6 centimeters.
In the central cone.
Yes. And right down to 1 centimeter. So couple of the interesting stories about the construction, they were in such a rush with the Cold War and Kennedy wanting everybody to get to the moon and getting assassinated that they actually poured the concrete for the foundation on Christmas Day 1960, and the entire place was up and running by July 1961.
Okay.
And as I say, they brought out all the parts for this telescope like a Meccano set.
Yes.
And you can actually see what I was talking about with the fact that they wouldn't take it away, couldn't take it away because it's built for this particular point on the Earth.
Yes.
The axis, you can see there's a big sort of, in fact you might see it better from the other side because it's bent over a little bit, but there's something that's angled like that.
Yes.
And that is aligned with the polar axis of the Earth. So it's a satellite laser ranger. It's called MOBLAS 6. So it's Mobile Laser Ranger 6, and there's several around the world. The US has loaned this to us. This is the Russian satellite laser ranger. So it does the same thing. It got a laser beam that goes out, tracks off GLONASS satellites, which is the Russian network.
Yes.
And then this building, this shed here is for a lunar laser ranger, which they're developing. So where the Russians remotely put sets of reflectors on the moon, and the Americans actually put sets of reflectors on the moon. So this is the 15 meter, and the origin of this was that with the whole idea of the SKA project coming up, and the fact that we have really good dry desert areas with little population, it was South Africa could enter into the bid for the square kilometer array project, and we needed to prove that we could build a radio telescope with a reasonable, price.
So this was a proof of concept that
exactly
then allowed the rest of the...
Yes. In fact, it was called the XDM, which is the experimental demonstrator model. So they built, we will get down there, they built the dish on the mold, and it's a carbon composite, sort of carbon fiberglass composite, and I'm not sure if the carbon is part of the fiberglass, but I know they put down sheets of fiberglass across the mold. And in fact, the mold was higher up at the time, so that people could actually walk underneath it. You'll see the mold in a minute. It's kind of falling apart a bit now. But the kind of idea of a big mold that you could then build something on and bring it in pieces, I think comes from the mining, where you have to take stuff down. So This is the computer that actually controls the telescope. And in fact, I think the software for this was done by the guy who's now Professor Justin Jonas. He was still doing his master's at the stage when I visited first in 1981 or something.
Yes.
And then he went on, continued the project he was doing into a doctorate, and I'll talk about the sky map is what he was doing. But I think he was the one who wrote the software that actually making the communicating with the telescope to make it move. Then you have to have this communicating with the software that actually runs the observing. So what that will need is two coordinates. So our angle and declination are basically just like longitude and latitude, but on the sky. And the hour angle is your east-west, and declination is your north-south. So you put in the two coordinates, and then the telescope needs to know where to go to point at. So it needs to know where the sky is. So you've got time, the universal time, that's the day of the year. So in astronomy, we don't worry with months and days because of February and all that problem. And then the time is out by 2 hours because that is universal time. It's the time that we use for these international experiments. So it's 2 hours behind us. So, but if you look at your watch and it's saying something, our watch is, it's correct, 10, so it's 10:56, so nearly is 5 to 11. Okay, so what's happening here is the telescope's pointing at a source, and then it's just standing there and letting the source drift through the telescope so that you get from where there's no source, you get to the center of the source and you you get past it. So it says it's a drift scan. This is a calibration thing. So what you do is you look at on source and then you look at the source looks sort of like that. That's called the beam pattern of the telescopes. So here we have the receiving equipment and recording equipment for the international experiment. So this one works on the 26 meter, and over here what we used to have was, you know, the kind of tapes that they used to have on these Mission Impossible or whatever, you know, the tapes that ran reel to reel on a thing.
Yes,
so we
yes,
used
yes.
to have those kind of tapes, which are about 4 hours.
Ooh, okay.
Then we went to 8-hour tapes, which basically fitted in here.
It's massive big set.
And still you would have to have people who stayed overnight with these experiments so that they could change tapes. And for me, the worst was I only came in at the 8-hour tapes, but the worst was that you had this tape and you had to run it through there, and then you had to make sure it ran around the next one, and you had to somehow and you had to, you know, and you don't know how many other people have licked that all around the world. But anyway, you kind of did it with your finger or whatever.
Yes.
And then you had to sort of get up at odd hours, because with the experiments, this is for the 15 meter antenna. This one's for the 26 meter. I'm just not sure whether it's, yeah, so that's showing various things from, I'm not even sure, it might be different channels, but that's sort of what's going on there. Then you'll have a similar thing there for the 15 meter. And after the tapes, we then went to disc packs, which if I can find one, I think they're around the back here. Oops. Wow, we used to have disc packs that stood all in the open, and now we don't seem to have one.
Are there efforts to that information? Is it still in tapes, or has it been digitized?
No. Well, what's happened is we've moved from tapes, because there's no longer a tape drive here.
Yes.
So we've gone on to digital. These are DVD. You can put a whole stack of DVDs. It's about, and I mean, it's terabytes of information.
Yes.
So you slot it in, and you can record onto it, and then if you switch it over, you can actually send that data overseas. We used to have to ship these things. Now we can send them, and as I say, now that we have the very wide bandwidth or whatever it is that comes into the country, but mostly for these experiments, we can actually do them real time.